Hello, friends, and welcome back to the Snoozy Scientist, where we gently explore the mysteries of our world, one sleepy yawn at a time. I'm really glad you made it here tonight, wherever you're tuning in from, whether wrapped beneath soft blankets, resting in a quiet chair, or letting your mind settle after a long day. This peaceful space has been made specially for you. Tonight, we are traveling to the farthest edge of our planet, a quiet boundary where human ambition fades and Earth decides what may pass. These are the places Earth keeps to itself. Across the surface of our world, nearly everything has been named, measured, and mapped. Yet science continues to find regions that remain functionally unreachable, not because they are hidden, but because distance alone does not define isolation. Some environments are separated from us by crushing pressure, by chemistry that burns lungs, by cold that stills machines, or by stretches of time so long that surface life has never touched them. In these spaces, survival is not a matter of skill or bravery. Studies suggest exposure is measured in minutes, sometimes seconds, and rescue is not delayed, it is impossible. Communication thins, systems fail, and even a brief human presence can permanently alter delicate conditions that have remained stable for millions of years. Scientists describe isolation in ways that sound almost gentle: environmental hostility, biological incompatibility, energy scarcity, and the simple fact that sustained presence cannot exist. As satellites pass overhead and instruments peer downward, a pattern becomes clear. In the deepest cold and the longest isolation, life continues without us, and sometimes only because we are not there. But why does Earth still contain places where human presence simply fails? What does isolation truly mean when survival, rescue, and even machines are no longer possible? How long can regions remain cut off before they become something entirely separate from us? And what happens to life when humans are permanently absent? Tonight, we will let science guide us gently toward the edges of human reach. But before we continue, if you're already settling in for this quiet journey, it would mean so much if you gave this video a gentle like or subscribed if you'd like more sleepy science adventures like this one. And if you feel like sharing, I'd love to know, where are you listening from tonight? What time is it there? It's always a joy to see how far across the world our little corner of curiosity reaches. So now, take a slow breath, let your shoulders soften, and together let us drift softly toward the places the earth still keeps to itself. Isolation, in science, is rarely a matter of miles on a map. It is measured instead by how quickly the human body begins to fail, how thin the margin for error becomes, and how completely a place resists being lived in. Distance can be crossed. Isolation must be endured, and many environments do not allow that endurance to last. As researchers came to understand this, isolation gained a quieter, more precise meaning. It was no longer defined by remoteness alone, but by a combination of forces that work together, often invisibly, to close a place to us. Environmental hostility was one of the first signs, not danger in the dramatic sense, but conditions that steadily dismantle the systems humans rely on to remain alive. Air that cannot be breathed, temperatures that steal heat faster than the body can replace it, pressures that distort tissues and overwhelm circulation. In such places, survival is not heroic or difficult, it is brief. Alongside this comes rescue impossibility. Science treats access as inseparable from return. A place is not considered reachable if help cannot arrive in time to matter. In many extreme environments, the window for survival is shorter than the fastest possible response. Communications degrade, vehicles fail, and even locating a person becomes uncertain. Isolation emerges not when something goes wrong, but when nothing can be done after it does. Energy scarcity deepens this divide. Human presence depends on a steady flow of power, heat, oxygen, and food. In hostile environments, energy drains away faster than it can be supplied. Batteries lose strength, fuel thickens or evaporates, and chemical reactions slow or accelerate beyond control. What sustains life elsewhere becomes an unstable burden here. Each hour requires more input than the last, until the cost of remaining exceeds what any system can provide. Then there is biological incompatibility, the quietest and often most overlooked barrier. Some environments are sealed ecosystems, shaped over immense spans of time without exposure to surface life. Introducing a human body with its warmth, microbes, and chemistry is not neutral, it is a disruption. Even careful presence can introduce organisms that outcompete local life or alter delicate balances that have persisted for ages. In these places, isolation functions as protection, preserving systems by excluding what does not belong. Together, these forces explain why a single visit does not equal access. Science draws a clear line between exploration and presence. Exploration is brief and fragile. It depends on layers of technology, careful timing, and controlled retreat. Presence requires continuity. It asks whether a place can support human life, not for moments, but for days, months, or generations. Most isolated environments fail this test completely. A brief descent, landing, or crossing may leave a trace in history, but it does not change the nature of the place. The environment does not open itself because it was touched once. It resumes its rhythms the moment humans leave. Instruments may gather data, samples may be retrieved, but the space itself remains closed. In this way, isolation is not broken by arrival, it is revealed by how quickly departure becomes necessary. Scientific language reflects this restraint. Researchers speak of exposure limits rather than endurance, of contamination risk rather than discovery, of tolerance thresholds rather than adaptability. These terms are not pessimistic, they are precise. They acknowledge that human biology evolved within a narrow envelope of conditions, and that most of Earth lies outside that envelope. What emerges from this understanding is a shift in perspective. The planet is not a collection of destinations waiting to be reached. It is a mosaic of environments, many of which were never meant to host sustained human life. Isolation, then, is not a failure of technology or ambition, it is a property of the environment itself. This distinction reshapes how scientists approach the most remote regions of Earth. The goal becomes observation without occupation, learning without imprint. Instruments are designed to be temporary, minimal, and cautious. Presence is reduced to data and then withdrawn. In this way, isolation is respected rather than conquered. Over time, this approach has revealed something quietly profound. Isolation is not emptiness. Many of the most inaccessible places are rich with life adapted to conditions humans cannot tolerate. Energy flows through unexpected pathways. Organisms persist without sunlight, without seasons, without contact. These systems do not wait for us, and they do not require us. Seen through this lens, isolation becomes less about exclusion and more about definition. It marks the boundaries of human compatibility, tracing the edges of where our bodies, technologies, and assumptions stop working. Beyond those edges, Earth continues on its own terms. As science refines its understanding, isolation is no longer treated as a challenge to overcome, but as a reality to acknowledge. The planet reveals its limits, not through spectacle, but through quiet refusal. Conditions remain unchanged, systems remain intact, and the absence of human presence becomes part of the stability of the place itself. In this way, isolation teaches patience. It asks observers to slow down, to accept partial understanding, and to recognize that access is not a right granted by curiosity. Some environments can be studied only from a distance, or through brief contact that leaves no lasting trace. Others remain closed entirely, not out of secrecy, but out of necessity. And so, in science, isolation settles into its true meaning, not far away, but incompatible, not undiscovered, but uninhabitable, not waiting, but complete. Beyond the coasts where ice meets restless seas, Antarctica turns inward. The continent rises gradually, almost imperceptibly, into a vast interior plateau that seems to withdraw from the rest of the world. Here, the cold is not a season or a storm, it is the background condition of existence, steady and absolute, shaping every surface and every second. As elevation increases, warmth disappears in layers, air thins and dries until moisture becomes rare enough to feel like an absence rather than a substance. The cold settles not only into the landscape, but into materials themselves. Metals lose flexibility, plastics stiffen, rubber becomes brittle, even breath behaves differently, crystallizing into fine clouds that linger briefly before vanishing into stillness. The interior cold is intensified by a powerful inversion. Dense air hugs the ice, heavier and colder than the layers above it, refusing to rise. Heat has nowhere to go and nowhere to arrive from. The ground radiates what little warmth it holds into a sky that offers nothing in return. In this balance, temperatures sink beyond what most environments on Earth ever approach. Instruments record values lower than those measured on the surface of Mars, not because space is closer here, but because Earth itself has created a perfect trap for cold. Wind moves across this plateau with quiet force. Katabatic flows descend from higher ice, pulled by gravity and chilled as they travel. They do not roar like storms. They slide, persistent and unyielding, stripping heat from anything exposed. Skin freezes in moments, not dramatically, but efficiently. Sensation fades first, then motion. The body responds too slowly to register warning before damage begins. Light becomes unreliable. For months at a time, the sun never rises. Darkness stretches without variation, dissolving the sense of day and night. Time is kept by clocks and routines rather than by the sky. In this prolonged night, the human body struggles to regulate itself. Sleep drifts, appetite shifts, hormones lose their familiar rhythm. Even thoughts can feel heavier, slowed by the sameness of cold and dark. Yet life persists within carefully maintained pockets. Research stations dot the interior like brief interruptions in an otherwise continuous expanse. They are not settlements in the traditional sense. They are supported presences, dependent on an unbroken chain of supply that stretches thousands of miles beyond the horizon. Every calorie, every liter of fuel, every replacement part must be delivered with precision. Nothing here is replenished by the environment itself. The stations endure because they are constantly fed from afar. Without aircraft, overland convoys, and seasonal windows of access, they would fall silent quickly. Fuel keeps generators alive. Generators keep heaters running. Heaters keep water liquid and air breathable. Each layer supports the next, and failure at any point ripples outward. The cold waits patiently for interruption. Machinery faces the same struggle as the human body, only without the ability to adapt. Lubricants thicken, bearings seize, electronics behave unpredictably as components contract at different rates. Batteries drain faster, chemical reactions slowed by the cold that surrounds them. Repairs are not simple acts of replacement. They require warming tools, protecting hands, and working against a temperature that erases dexterity. The interior also resists sound and movement. Snow here is not soft in the familiar sense. It is compacted by time and pressure into a surface that squeaks and fractures underfoot. Vibrations travel differently through the ice, absorbed rather than echoed. Distance becomes difficult to judge, as shadows flatten and depth cues vanish. The horizon offers no landmarks, only a pale curve where ground and sky blend into one. Biology retreats to the margins. There are no plants rooted in this interior, no animals roaming its surface. The absence is not dramatic. It feels complete, as though life simply chose not to enter. Microbial communities exist within the ice itself, dormant and sparse, waiting through spans of time measured far beyond human schedules. They do not interact with the surface world in any visible way. They persist quietly, sealed within crystal. In this environment, presence is always provisional. Humans do not arrive and remain. They cycle in and out, synchronized with logistics and weather windows. The interior does not soften with familiarity. It does not respond to repeated visits. Each arrival begins again, as though no one had ever been there before. Antarctica's interior rejects life not through sudden violence, but through consistency. The cold does not surprise. It endures. It removes options one by one until only the narrowest path remains. Along that path, survival depends on preparation, cooperation, and constant attention. Outside it, the plateau remains unchanged. As the long darkness continues and the ice holds its silence, the interior stands as one of Earth's most complete refusals. Not hostile in anger, not forbidding in drama, simply unwavering. A place shaped so precisely for cold that life, as humans know it, can only touch the edges before retreating once more into warmth. Beneath the vast stillness of Antarctica's interior, far below the winds and the long darkness, another world rests in silence. It does not announce itself on the surface. There is no opening, no fracture, no visible sign that anything lies below. Only ice, layered patiently over immense spans of time, pressing downward with steady, unrelenting weight. Deep beneath nearly 4 kilometers of that ice, Lake Vostok remains liquid. Its existence is not intuitive. In a place where cold dominates everything above, liquid water seems almost out of place, yet pressure changes the rules. The immense mass of ice lowers the freezing point, while subtle geothermal warmth from Earth's interior provides just enough energy to keep the water from locking into solid crystal. The lake persists not through abundance, but through balance. Lake Vostok has been sealed away for millions of years. No sunlight reaches it, no air circulates through its depths. There are no seasons, no surface disturbances, no storms to stir the water. Time here moves differently, marked not by days or years, but by the slow drift of ice above and the quiet chemistry of water below. The pressure is extraordinary. The ice overhead bears down with the weight of entire mountain ranges. Every drop of water exists under forces far beyond what the human body could tolerate. Yet within that pressure, the lake remains stable, held in a delicate equilibrium that has endured while continents shifted and climates rose and fell far above. Because it is sealed so completely, Lake Vostok is isolated in the purest scientific sense. It is cut off from sunlight, from atmospheric gases, from surface organisms, any life that exists within it, if life exists at all, has evolved without contact with the world humans know. Energy, if present, must come from chemical interactions between water and rock, or from trace elements released slowly over time. Survival here would rely on patience rather than speed, efficiency rather than abundance. When scientists first inferred the lake's presence through radar and seismic signals, excitement was tempered by caution. This was not a place to be rushed toward. The very isolation that made Lake Vostok fascinating also made it fragile. Introducing surface microbes, heat, or chemical contaminants could permanently alter a system that had remained unchanged for geological ages. Drilling through nearly 4 kilometers of ice is not a simple act. It generates heat. It requires fluids to prevent refreezing. It creates a pathway between two worlds that have never touched. Scientists understood that reaching the lake could not be undone. Once opened, even briefly, it would never again be entirely sealed. Because of this, fear of contamination outweighed the desire for discovery. Protocols were debated, revised, and slowed. Technologies were redesigned to minimize intrusion. The goal shifted from access to restraint. Knowing the lake existed became enough. For a time, observation replaced contact. In this way, Lake Vostok changed how isolation was treated in science. It was no longer only a barrier to overcome, but a condition worth preserving. The lake was valuable not just for what it might reveal, but for what it represented. A reminder that some systems remain intact precisely because they have never been entered. The ice above acts as both shield and archive. Trapped bubbles preserve ancient atmospheres. Layers record shifts in climate long past. The lake below remains untouched by those changes, insulated from surface chaos by a frozen ceiling that renews itself slowly over millennia. This separation has allowed two timelines to exist in parallel, one dynamic and exposed, the other quiet and continuous. Any life within Lake Vostok would be shaped by constancy. No light cues, no sudden changes, no external competition. Metabolism would move slowly, conserving energy in an environment where nothing is wasted. Growth would be measured in patience rather than speed. Adaptation would favor stability above all else. Standing above such a place, even indirectly, science becomes careful with its language. Discovery gives way to stewardship. Curiosity learns to pause. The lake does not need to be entered to teach what it has already shown. That isolation can preserve, not just exclude. That absence can protect complexity. That some of Earth's most profound stories are written in places that remain closed. Lake Vostok continues to rest beneath the ice, unchanged by attention, unmoved by interest. It exists without witnesses, without disturbance, and without need for explanation. In its sealed darkness, it holds a version of Earth that has never known the surface, quietly reminding science that not all knowledge requires contact, and not all frontiers are meant to be crossed. Beyond the sheltered interiors of research stations and far from the icebound coasts, the Antarctic Plateau stretches outward in quiet enormity. It appears calm, even simple, a pale expanse beneath a wide sky. Yet this calm hides a relentless test, one aimed not first at human bodies, but at the machines built to protect them. On the plateau, technology enters an environment where its assumptions begin to unravel. Fuel, which elsewhere flows freely, thickens as temperatures sink. Liquids meant to power engines grow sluggish, then waxy, then nearly solid. Pumps strain, lines clog. What once moved with ease now resists every attempt at motion. Energy becomes difficult to release, not because it is absent, but because cold locks it away. Metals respond in their own way. Steel, aluminum, and alloys contract as the temperature drops, shrinking by fractions that matter deeply at this scale. Bolts loosen. Seals lose their grip. Hairline cracks form silently, spreading through stressed components with each cycle of use. Materials designed for strength reveal another property here: brittleness. Under strain, they fracture without warning, snapping cleanly instead of bending. Even simple tools change character. Wrenches bite harder against frozen surfaces. Gloves reduce dexterity until fine adjustments become slow negotiations between fingers and fabric. Repairs that would take minutes elsewhere stretch into careful, deliberate rituals performed against time and temperature. Electronics face an even quieter failure. Batteries drain rapidly as chemical reactions slow. Screens fade, then go dark. Sensors report values that drift as internal components contract at different rates. Circuits that rely on precise timing lose synchronization. Data becomes uncertain, not because the environment is unknown, but because the instruments themselves can no longer agree on what they are sensing. The cold seeps into everything. It infiltrates housings, cables, and joints. Insulation helps, but it only delays the inevitable. Machines require warmth to function, and warmth is the rarest resource on the plateau. Every watt of heat must be generated, contained, and defended against loss to an environment that absorbs it effortlessly. This is why technology reaches its limit before humans do. The human body, though vulnerable, is adaptable within narrow margins. With shelter, clothing, and discipline, people can endure conditions that break equipment. Machines, by contrast, depend on precise tolerances and stable states. When those conditions vanish, reliability vanishes with them. Vehicles designed for polar travel illustrate this clearly. Engines must be kept running or carefully heated, as restarting in extreme cold risks permanent damage. Tires harden. Hydraulic systems respond sluggishly. A single stalled vehicle becomes not just an inconvenience, but a fixed object in a landscape that offers no assistance in recovery. Communications systems struggle as well. Antennas ice over, signals weaken as power supplies falter, distance amplifies every flaw. On the plateau, a minor malfunction can isolate an entire operation, not through dramatic collapse, but through gradual loss of function. Because of this, presence on the Antarctic Plateau is built around anticipation of failure. Redundancy becomes a guiding principle. Systems are duplicated, sometimes triplicated. Spare parts are stockpiled. Maintenance is constant, not occasional. Every action assumes that something, somewhere, will stop working sooner than expected. Even with these precautions, technology never truly settles here. It operates on borrowed time, surviving through careful management rather than harmony with the environment. The plateau does not accommodate machines, it tolerates them briefly. Humans move within this fragile envelope, aware that their safety depends on devices that are always nearing their limits. The relationship is inverted compared to most places on Earth. Instead of technology extending human reach, humans devote much of their effort to sustaining technology itself. Keeping systems alive becomes a daily act of attention. The plateau reveals a subtle truth about isolation. It is not only the body that must survive, every supporting structure must endure as well, without pause. When even the smallest component fails, the chain weakens. In such a place, complexity becomes vulnerability. As days pass beneath the unchanging sky, the machines continue their quiet struggle. Some endure longer than expected, others fail without explanation. The plateau remains indifferent to both outcomes. It neither challenges nor welcomes. It simply exists within conditions that favor simplicity and patience over precision and speed. In this high, frozen stillness, the limits of technology become visible, not as dramatic endings, but as gradual silences. Engines cooling, screens darkening, signals fading into static. And beyond them, the plateau remains, vast and unchanged, reminding all who enter that here, survival begins with the machines and often ends with them. Beyond the plateau's frozen heights and far from the reach of wind and sky, Antarctica extends downward into another hidden realm. Here, the ice does not rest on land alone. It flows outward, thick and slow until it meets the sea and spreads into vast floating shelves. Beneath these shelves, the ocean enters a state unlike any other on Earth. Light never reaches this water. Not a trace of dawn or dusk, not a glimmer filtered through waves. Above, hundreds of meters of ice seal the surface completely, turning day and night into an idea that no longer applies. Darkness here is not the absence of light after sunset. It is a permanent condition, steady and uninterrupted. Without light, there are no seasons. The slow tilt of Earth, so influential elsewhere, has no voice beneath the ice. Temperature remains nearly constant. The water holds close to its freezing point, dense and heavy, moving in gradual currents shaped by salinity and pressure rather than by storms or sunlight. Time passes without visible markers, measured only by subtle chemical shifts and the slow exchange between ice and sea. Life here follows rules that feel almost unfamiliar. Without sunlight, photosynthesis never begins. There are no drifting blooms, no green pulses of energy rising from the surface. Instead, life draws its strength from chemistry. Minerals leach from rock below. Compounds released from the ice dissolve slowly into the water. Microbes use these ingredients the way surface life uses light, extracting energy through reactions that unfold molecule by molecule. This form of life moves quietly. Growth is slow. Reproduction is deliberate. Organisms are often small, efficient, and patient, adapted to an environment where nothing arrives quickly and nothing leaves easily. Food webs are simple but stable. Energy circulates through pathways that have persisted for immense spans of time without interruption. The ice shelf above is not inert. It breathes slowly, melting at its base and refreezing in layers shaped by ocean currents. Fresh water mixes with salt, creating gradients that influence circulation. Nutrients travel along these hidden boundaries, feeding communities that cling to the underside of ice or drift within the dark water below. In this environment, even small disturbances matter. The system has evolved without surface influence, without debris, noise, or heat introduced from above. It is isolated not only by distance, but by history. When humans enter this space, even indirectly, they arrive carrying warmth, particles, and microorganisms that do not belong. Because of this, humans are considered pollutants here, not in a moral sense, but in a scientific one. A single introduced microbe can outcompete native species. A trace of oil or metal can alter chemical balances that have remained stable for ages. Sound and vibration can disrupt organisms adapted to stillness. Heat changes density, altering currents that shape the entire system. For researchers, this creates a delicate challenge. Studying the ocean beneath ice shelves requires drilling through thick ice, lowering instruments into darkness, and withdrawing them without leaving a trace. Every action is designed to minimize contact. Equipment is sterilized. Access points are sealed again as carefully as possible. Observation is favored over interaction. The reason for this care lies in the nature of the ecosystem itself. It functions precisely because it has been left alone. Its stability is not resilience against disturbance, but avoidance of it. Introducing change does not trigger recovery. It rewrites the system. Yet even without direct human presence, this hidden ocean is changing. Shifts in global temperatures influence how much ice melts from below. Currents adjust. Freshwater input alters circulation patterns. These changes travel silently beneath the ice, affecting ecosystems that have never known variability on this scale. Still, the world beneath the ice shelves remains one of Earth's most isolated living systems. It operates beyond sight, beyond sound, beyond human rhythm. Life here does not hurry. It does not compete aggressively. It persists through balance and restraint, shaped by chemistry and time, rather than by light and motion. When instruments are withdrawn and the ice seals once more, darkness returns to its uninterrupted state. The water continues to move slowly, reactions proceed at their patient pace. Organisms carry on without awareness of having been observed. In this place, isolation is not emptiness. It is a condition that allows life to exist in forms both ancient and precise. The absence of humans is not a loss. It is part of the structure that keeps this world intact. Beneath the Antarctic ice shelves, the ocean remains quietly alive, sustained by forces that ask nothing from the surface above. In its permanent darkness and steady cold, it holds a reminder that some of Earth's most enduring systems flourish, not despite isolation, but because of it. From the frozen silence beneath Antarctic ice, Earth's story descends into a different kind of depth. The ocean opens downward, not as a slope but as a sudden release, a vertical distance that pulls water and pressure into an unfamiliar arrangement. Here, the surface world fades quickly, light thins, color drains, and motion slows until the sea becomes a column of weight pressing steadily toward the planet's crust. The Mariana Trench lies within this descent, a narrow scar where the ocean floor folds inward. It is not wide or dramatic when viewed on a map. Its power comes from depth alone. Water gathers above it, layer upon layer, until the mass becomes almost unimaginable. Pressure increases quietly with every meter, not as a shock but as a constant accumulation. By the time the trench floor is reached, the force is enough to crush steel as if it were thin foil. This pressure does not arrive suddenly. It builds patiently, evenly distributed, pressing against every surface with the same insistence. There is no direction to it, no way to lean away. Objects brought here must be designed to accept the pressure entirely or be reduced to fragments. Human bodies cannot adapt to this condition. It is not a challenge of endurance or strength, but of structure. Our cells, our tissues, our chemistry are not built to exist under such weight. The water itself remains near freezing. Cold settles into the trench, dense and heavy, moving only slightly over long spans of time. There is no seasonal warmth, no mixing driven by wind or sun. Temperature remains stable, locked into a narrow range that preserves pressure and slows motion. In this cold, reactions unfold at a measured pace, unhurried and precise. Life persists here, but it does so in ways shaped entirely by these conditions. Organisms are compact, flexible, and resilient. They lack air spaces that would collapse under pressure. Their chemistry resists crushing force, allowing proteins and membranes to function where they would fail elsewhere. Many produce their own faint light, not to illuminate space, but to signal briefly in darkness that has never known a surface glow. Humans have reached the Mariana Trench. This fact often sounds more triumphant than it deserves. Descents have occurred, carried out within carefully engineered vessels designed to survive minutes or hours under pressure that would instantly end unprotected life. These journeys are controlled, brief, and entirely dependent on technology that remains at the edge of failure. Reaching the trench does not make it accessible. A short visit leaves no path behind, no shelter, no ability to remain. The moment the descent ends, the ascent must begin. There is no option to stay. There is no way to adjust if something goes wrong. Presence here is always temporary, defined by the limits of the vessel rather than by the environment. Rescue is impossible in any meaningful sense. The depth alone prevents it. Signals take time to travel. Vehicles cannot descend quickly. The pressures involved demand careful, slow movement to avoid catastrophic failure. If a system fails on the seafloor, there is no backup arriving from above. The ocean closes in, patient and absolute. This reality shapes how science treats the trench. Exploration is cautious and rare. Instruments are designed to withstand pressure for long periods without maintenance. Data is collected remotely, often without human eyes present. The trench is observed more than visited, measured rather than entered. In this way, the Mariana Trench becomes a lesson in the difference between touching a place and living within it. Human reach extends downward through ingenuity and preparation, but it does not linger. The environment remains unchanged by these brief encounters. Pressure does not ease. Cold does not retreat. Life continues on its own terms, shaped by forces that ignore human ambition entirely. The trench does not resist out of hostility. It simply exists at a depth where the rules humans rely on no longer apply. Gravity, chemistry, and time arrange themselves differently here. Survival is not negotiated. It is either structurally possible or it is not. When vessels rise again toward the surface, carrying samples and recordings, the trench returns to darkness. Water settles back into its slow movements. Bioluminescent flashes fade into the distance. Nothing waits for the next visit. Nothing changes in anticipation of it. The Mariana Trench remains reachable only in the narrowest sense. It allows observation without offering refuge. It permits contact without granting access. In its cold, crushing depths, it stands as a quiet boundary, marking a place where human presence can arrive briefly, but never remain. Below the depth reached by familiar submarines, the ocean continues downward into a realm that remains almost entirely untouched. This region is known as the Hadal Zone, named for the ancient idea of an underworld, though its reality is quieter and far more precise. It exists in narrow trenches scattered across the ocean floor, places where Earth's crust has folded inward and allowed the sea to sink deeper than anywhere else. Here, depth is not a gradual transition, it is a threshold. The water above presses down with a weight that reshapes matter itself. Pressure increases steadily until it becomes the dominant force, stronger than temperature, stronger than motion. Everything that exists here does so under a constant, unrelenting squeeze. Most submarines never come close. Their hulls are designed for great depths, but not for this. Steel and titanium have limits, and the Hadal Zone rests beyond them. Only a handful of specialized vessels have ever descended this far, and even those visits were brief, carefully planned, and dependent on flawless engineering. The vast majority of the Hadal Zone has never been seen directly by human eyes, yet life exists throughout it. Organisms here are not visitors. They are natives, shaped over immense spans of time by pressure that would destroy surface life instantly. Their bodies are built without empty spaces that could collapse. Their tissues remain flexible where rigidity would fail. Proteins fold differently, maintaining function where familiar biological structures would unravel. Chemistry itself behaves in altered ways, tuned to survive where force is constant and overwhelming. Movement is slow and deliberate. Energy is precious. Food arrives rarely, drifting down from far above or produced locally through chemical reactions that unfold without sunlight. Many organisms are small, but not fragile. They are resilient in a way that reflects patience rather than strength. Color has little meaning here. Light does not penetrate from the surface, and bioluminescence appears only in brief flashes, signals rather than illumination. The darkness is complete and permanent, not something that arrives with nightfall, but something that has always been present. The Haddle Zone is not chaotic. It is remarkably stable. Temperature changes little. Currents move slowly. Seasons do not reach this depth. Life proceeds at a measured pace, shaped by consistency rather than variation. Evolution here favors efficiency and durability, traits that allow survival without abundance. Humans cannot adapt to this environment, not because of fear or unfamiliarity, but because the limits are structural. The human body depends on pressure ranges found near the surface. Cells, blood vessels, and organs are built for balance, not compression. No amount of training or technology can change this fundamental mismatch. Protection can be engineered briefly, but adaptation would require an entirely different biology. Even if pressure were somehow managed, other barriers remain. Temperature hovers near freezing. Food is scarce. Energy cannot be generated easily. Communication becomes unreliable. Rescue, as understood on the surface, does not exist. Distance is measured not just in meters, but in time required to ascend safely through pressure gradients that cannot be rushed. Because of this, the Hadal Zone remains Earth's least touched biosphere. It is not unexplored because of neglect, but because access itself is incompatible with sustained presence. Instruments are lowered carefully and retrieved. Data is gathered remotely. Samples are rare and precious. Observation happens through patience rather than intrusion. What science has learned so far suggests that this region is not marginal or impoverished. It is simply different. Life here follows rules that feel unfamiliar only because they operate outside human experience. Ecosystems persist without light, without plants, without warmth. They do not require disturbance to remain active. They function quietly, efficiently, and continuously. The Hadal Zone also offers perspective. It reveals that much of Earth's living space exists beyond human reach, not as an exception, but as a norm. The environments most compatible with humans occupy only a thin layer near the surface. Below that, the planet belongs to pressures and chemistries that do not bend to us. As instruments rise back toward the light, carrying recordings and measurements, the Hadal Zone closes again behind them. Nothing shifts to mark their passing. No trace remains. Life continues at its own pace, unchanged by attention. In this deepest layer of the ocean, isolation is complete and enduring. The Hadal Zone does not reject humans actively. It simply exists beyond the boundaries of adaptation. It stands as a reminder that Earth holds entire biospheres that thrive without ever noticing us, vast and living spaces shaped by forces that require no audience at all. As the year turns and the sun withdraws from the far north, the Arctic Ocean enters a state of quiet withdrawal. Light fades day by day until it no longer returns at all. What remains is not night in the familiar sense, but a long, unbroken darkness that settles over sea and sky alike. The horizon disappears. Direction becomes uncertain. The world narrows to what can be felt rather than seen. In winter, the Arctic Ocean is never still. Ice forms, thickens, fractures, and reforms in constant motion. Vast sheets drift under the pull of wind and current, grinding slowly against one another. Pressure ridges rise where plates collide, lifting walls of ice that can tower above the surface. Leads open without warning, long cracks of dark water that steam faintly in the cold air before closing again. Nothing remains fixed for long. The darkness deepens this instability. Without sunlight, the subtle cues that guide navigation vanish. There is no color to separate ice from sky, no shadow to suggest distance. Sound travels strangely across frozen surfaces, sometimes carried far, sometimes swallowed completely. Even experienced crews describe a sense of disorientation, as if the ocean has erased its own boundaries. Beneath the ice, the water holds its own form of danger. Temperatures hover just above freezing, dense and heavy. Cold water shock arrives almost instantly upon exposure. The human body reacts before thought can form. Breath is pulled inward sharply, muscles seize, coordination falters. In these conditions, survival is measured in minutes, often less. Protective clothing can extend that window slightly, but rescue must be immediate to matter at all. In winter, rescue is rarely possible. Ice blocks access from above. Storms sweep in without warning, driven by temperature contrasts and shifting pressure systems. Helicopters cannot land safely. Ships struggle to maneuver through ice that moves faster than engines can respond. Communication systems fail more often in the cold, batteries draining rapidly as chemical reactions slow. For vessels, the Arctic winter is a test few are designed to endure. Hulls reinforced for icebreaking can still be trapped by converging flows. Rudders and propellers are vulnerable to damage from submerged ice. Fuel thickens. Intake systems freeze. Even when engines remain functional, progress becomes uncertain. A ship may move forward 1 hour, only to be carried backward the next by drifting ice. Navigation relies heavily on satellite data, yet even this assistance has limits. Ice conditions change faster than maps can update. What appears navigable one moment may close entirely the next. The margin for error is narrow, and mistakes compound quickly in an environment that offers no safe harbor. Because of this, most ships avoid the Arctic Ocean in winter altogether. Routes that pass through in summer fall silent as ice expands. Commercial traffic halts. Research expeditions withdraw. The ocean is left largely to itself, occupied only by ice, water, and the few organisms adapted to endure this season. Life here does not pause, but it slows. Beneath the ice, plankton communities wait for light that will not return for months. Fish move deliberately, conserving energy. Marine mammals surface through breathing holes that must be maintained constantly, revisiting the same openings again and again. These animals navigate by memory, sound, and instinct, following patterns shaped over generations. Above the ice, the atmosphere grows heavier with cold. Moisture crystallizes into fine particles that hang in the air. Snow drifts across the surface, reshaping familiar features and erasing tracks within hours. The landscape rewrites itself repeatedly, leaving no reliable reference points behind. Human presence in this season feels provisional, always temporary. Even the most capable icebreakers plan for withdrawal, timing their movements carefully to avoid being caught as daylight fades completely. Winter does not welcome improvisation. It rewards caution and restraint. As darkness continues and ice grinds softly against itself, the Arctic Ocean enters a state of isolation that feels complete. Not sealed away like a buried lake, not crushed by pressure like the deep sea, but rendered inaccessible through motion and cold combined, it remains open water in theory, yet closed in practice. In winter, the Arctic Ocean belongs to processes that move slowly and relentlessly, indifferent to schedules or ambition. Ships turn away not out of fear, but out of respect for limits that cannot be negotiated. The ice continues its drift. The darkness holds, and the ocean persists, vast and self-contained, through a season that quietly excludes almost everything that tries to cross it. From the cold silences of ice and depth, Earth's story turns toward heat. Not the familiar warmth of deserts or tropics, but a kind of heat that feels foundational, as if the planet's inner processes have surfaced and refuse to be hidden. In northeastern Africa, where tectonic plates pull slowly apart, the land opens into the Danakil Depression, a place shaped less by distance than by chemistry itself. The Danakil lies below sea level, yet it is not defined by water. Instead, it is a basin where heat accumulates and lingers, trapped by geography and geology. Sunlight arrives with intensity, but it is only one part of the equation. Beneath the surface, magma moves close enough to warm the ground continuously. The air above becomes heavy and stagnant, holding heat long after night should have offered relief. Temperatures here climb beyond what most environments sustain. Day after day, the heat remains, pressing against the body without pause. Sweat evaporates almost as quickly as it forms, offering little cooling. Dehydration begins before thirst has time to signal. Movement slows, not from fatigue alone, but from the body's need to conserve what little balance it can maintain. Across the landscape, chemistry announces itself openly. Bright pools of liquid shimmer in unnatural colors, greens, yellows, and whites that seem almost luminous under the sun. These are not reflections of life, but of dissolved minerals and acids drawn upward from deep within the earth. The water burns on contact. Vapors rise, sharp and acrid, carrying sulfur and other gases that irritate lungs and eyes within moments. Toxic gases seep from vents and fissures, invisible yet present. Some are heavier than air, settling close to the ground where they linger quietly. Breathing becomes an act of caution. A shift in wind can change conditions instantly, turning a passable stretch of land into a place where exposure must be brief. The danger does not announce itself loudly. It arrives as a tightening in the chest, a sting in the throat, a warning delivered too late for comfort. Acid pools dot the depression like open wounds in the crust. Their surfaces ripple gently, deceptively calm. Crystals form along their edges, sharp and fragile, breaking underfoot with a sound like glass. The ground itself can be unstable, hardened crust concealing softer layers beneath. Each step requires attention, not because the terrain is dramatic, but because it is chemically active. Despite these conditions, the Danakil is not lifeless. Microorganisms thrive here, adapted to extremes of heat, acidity, and salinity that would destroy most known life. Their presence is subtle, often visible only as thin films or faint discolorations. They draw energy directly from chemical reactions, converting minerals and gases into sustenance. Their world operates independently of human tolerance, following rules written in molecules rather than comfort. For humans, isolation in the Danakil is not created by remoteness. Roads lead close. Settlements exist on the margins. The boundary is not enforced by distance or by lack of access, but by incompatibility. Prolonged presence demands constant support. Water must be carried in. Protective equipment becomes essential. Exposure limits are measured carefully, not out of fear, but necessity. Even machines struggle here. Heat affects electronics, shortening lifespans and causing unpredictable failures. Corrosion accelerates as acids attack metal surfaces. Plastics degrade. Seals weaken. Equipment that performs reliably elsewhere requires frequent maintenance if it can function at all. The environment does not resist technology actively. It simply continues its chemical processes without accommodation. The air itself feels altered, thicker with heat, heavy with scent. Sound carries differently across salt flats and hardened lava, muffled by distance and shimmer. Visual illusions appear as the ground radiates heat upward, bending light and blurring edges. The horizon seems closer than it is, then suddenly farther away, as if space itself is uncertain. Because of this, time in the Danakil is carefully rationed. Expeditions move slowly, pausing often. Observation replaces exploration. The goal is not to linger, but to pass through with minimal disturbance. The depression does not invite habitation. It tolerates only brief attention. As evening approaches, temperatures ease slightly, but the land does not cool in the way one might expect. Heat stored in rock and salt releases slowly, extending the day's intensity into the night. The stars appear sharp above, contrasting with the harshness below. Even in darkness, the chemistry continues, unseen but active. The Danakil Depression stands as a reminder that isolation does not always lie at the ends of maps. Sometimes it exists in plain sight, enforced by reactions that never pause. Here, Earth excludes not through cold or pressure, but through heat and chemistry combined. It is a place where distance means little, and presence is defined entirely by how long a body can endure before the environment quietly insists otherwise. From places shaped by ice, pressure, depth, and heat, the story moves to a different kind of boundary. One not carved by geology or climate, but by a moment in human history that altered a landscape in ways no map could fully capture. In northern Ukraine, forests and fields continue to grow around a quiet center known as Chernobyl's exclusion zone. Here, isolation was not planned. It arrived suddenly, carried by particles too small to see and powerful enough to change how a region could be used for generations. Radiation became a barrier more absolute than walls or distance. It did not block entry with force. It lingered, settled, and remained. After the evacuation, human activity faded quickly. Roads emptied, homes were left behind with meals unfinished and windows open to the air. Schools, hospitals, and factories fell silent. The land was not sealed, but it was abandoned, set aside by necessity rather than choice. The exclusion zone formed not because the place disappeared, but because human presence could no longer continue safely. Radiation behaves differently from other hazards. It does not announce itself through sound or smell. It does not alter the shape of the land. It exists invisibly, woven into soil, plants, and structures. Exposure accumulates quietly, measured not in moments of danger, but in long-term risk. This subtlety makes it an effective boundary. People cannot sense when they have crossed it. Instruments must speak on their behalf. In the absence of humans, something unexpected unfolded. Wildlife returned. Forests reclaimed streets. Roots cracked pavement. Buildings softened under vines and moss. Within years, animals began moving back into the region. Wolves established territories. Elk and deer wandered freely. Birds nested in abandoned structures. The landscape, once shaped around human schedules and noise, shifted toward patterns defined by seasons and instinct. This return was not simple or uniform. Radiation affects living organisms in complex ways. Some areas remain more hazardous than others. Certain species experience higher mutation rates or reduced lifespans. Yet overall, population numbers increased. In many cases, the absence of humans proved more influential than the presence of radiation. Without farming, hunting, traffic, or development, ecosystems reorganized. Fields became meadows, meadows became forests, rivers flowed without regulation. Predators returned to spaces where they had been pushed out long before the accident. Life adjusted, not because conditions were ideal, but because pressure from human activity had been removed. Chernobyl became an unintended experiment in isolation. Scientists did not design it as a study, but over time, it offered rare insight into how landscapes respond when humans leave abruptly. Researchers observed how ecosystems function without management, without restoration efforts, without interference. The zone revealed resilience alongside vulnerability, complexity alongside damage. Radiation remains a defining feature, shaping where and how life persists. Some species avoid hotspots, others tolerate or adapt to them. The land holds a mosaic of conditions, varying from place to place, reminding observers that isolation does not create uniform outcomes. It creates space for processes to unfold without constant direction. For humans, presence in the exclusion zone is carefully controlled. Visits are timed and monitored. Protective measures are routine. Time spent is limited. The boundary remains, enforced not by guards alone, but by long-term risk that does not diminish quickly. Even decades later, the land carries a memory that cannot be erased. Yet the zone does not feel empty. Wind moves through trees that were once streets. Footprints of animals replace tire tracks. Night returns without artificial light, allowing stars to reclaim the sky. The silence here is layered, carrying echoes of what once was and what has grown in its place. Chernobyl challenges assumptions about isolation. It shows that removal of humans can allow ecosystems to recover, even under imperfect conditions. It also shows that some boundaries, once crossed, cannot be undone. The land adapts, but it does not forget. This place stands apart from the others in this journey, not sealed by ice or pressure, not crushed by depth or heat. Its isolation is social and biological, shaped by human technology and its consequences. It reminds science that absence can reshape a landscape as profoundly as presence. Within the exclusion zone, life continues without invitation or apology. It grows around reminders of human absence, weaving nature through concrete and steel. The barrier remains invisible, persistent, and real. And within it, Earth carries on, demonstrating that isolation, even when unintended, can open space for worlds to exist beyond our reach. Far from continents and currents, where the Indian Ocean stretches endlessly between islands and reefs, lies a place almost unchanged by time or touch. North Sentinel Island appears at first glance as a green jewel rising from the sea, its beaches pale and its forests dense, yet the life within it exists in a rhythm entirely separate from the world around it. Here, isolation is not a recent condition imposed by law or geography. It is a survival strategy honed over tens of thousands of years. The people of this island live in a world without outsiders. Their communities have developed in remarkable continuity, guided only by local knowledge and generations of inherited skill. Paths wind beneath canopies that filter sunlight into dappled patterns. Trees bear fruit that sustains entire families. Birds and fish provide nourishment. Life unfolds in a delicate balance, where every movement of the body, every action, responds to the subtle cues of the environment. The island is fully inhabited, yet the inhabitants remain hidden from most maps and histories, their culture preserved through careful seclusion. Isolation here is not an absence of danger. It is a shield, one that has proven necessary to survival. Contact between humans, from the outside world, and the island's residents is extremely risky. The people are immunologically naive. They have never encountered many pathogens that travel easily across oceans. A virus, bacteria, or common cold brought inadvertently could spread quickly, overwhelming a population that has no prior exposure. The effects would be swift and devastating, a reminder that presence alone can carry danger. The risk is not one-sided. Visitors also face perils inherent to the island's isolation. The community maintains its boundaries with vigilance. Defensive actions, whether by projectiles or other means, are responses honed over generations to protect home and family. A person approaching without understanding the environment, the tides, or the people's customs may encounter hazards as immediate as the sharp edges of coral, the currents of surrounding waters, or the defensive actions of those who know the land intimately. In this way, the island enforces its own boundary, biologically and culturally, maintaining separation as a form of protection. The forests and shorelines themselves reinforce isolation. Dense vegetation conceals movement. Beaches are narrow and lined with rocks and fallen trees, limiting safe landing points. Even those attempting observation from a distance can perceive little of the interior life, as the trees and undergrowth absorb sound and hide structures from view. Time and persistence offer no guarantee of understanding, as the island exists on its own schedule, its cycles independent of the world beyond the waves. North Sentinel Island also demonstrates how isolation preserves complexity. Within its boundaries, ecosystems remain intact. Flora and fauna follow patterns shaped without significant interference. Predator and prey interact naturally. Soil, water, and vegetation maintain cycles that have evolved quietly for millennia. The human presence that does exist here has adapted to local conditions, living lightly in a balance that is fragile to outsiders. Because of these factors, contact itself is considered lethal, not out of intention, but out of consequence. The island maintains separation naturally, and interference would almost certainly bring harm to both sides. Respecting its isolation means observing boundaries from afar, acknowledging a world that has thrived without intrusion, and accepting that some communities are meant to remain unseen and untouched. In this remote place, isolation is absolute, enforced biologically, culturally, and geographically. It is a form of survival preserved over tens of thousands of years, a living testament to the power of separation. North Sentinel Island exists quietly, fully, and independently, a rare example of human life continuing in parallel with the larger world, untouched except by the tides and the passing of time. Beneath the familiar contours of Earth, hidden from sun and sky, lie networks of passages carved slowly over millennia. These are deep cave systems, veins of stone and water threading quietly through mountains and plateaus, places where the world above feels distant and almost irrelevant. Entering them is not a journey outward, but a descent into a realm governed by subtle pressures and unseen currents, a world measured in breaths and balance rather than distance. Air itself behaves differently in caves. As one moves deeper, oxygen begins to thin. Small pockets may hold just enough for careful passage, yet the larger chambers often feel heavier, thicker. Each inhalation requires more effort, and each step becomes an unspoken negotiation with the environment. Time is marked less by minutes on a watch than by the body's slow recognition of scarcity, the pulse of lungs growing insistent in a place where every breath matters. Oxygen depletion is silent, invisible, yet immediate in its effect. It shapes how humans move, how quickly they tire, and how steadily they must measure every exertion. Water is never far away in these passages. Underground streams, formed by melting snow or seepage from above, wind through tunnels with patience. During periods of rain or snowmelt, these channels swell. Flooding can rise without warning, submerging passages that seemed passable moments before. The sound of rushing water echoes unnaturally, magnified by stone walls that have stood unchanged for eons. Even shallow pools can conceal depth and current, while sudden rises in water levels create currents that challenge strength and stability. In caves, water is both guide and threat, shaping movement and defining boundaries where walls alone do not. The labyrinthine nature of these systems adds another layer of danger. Twisting corridors and repeating formations can erase any sense of direction. Even explorers with careful mapping often find themselves disoriented, turning familiar junctions into confusing loops. Shadows stretch strangely, rocks appear alike, and the ceiling's low points or protrusions disrupt rhythm. Sound carries unexpectedly, creating illusions of space that do not exist. For those who venture deep, disorientation is a constant companion, subtle at first, then insistent, eroding confidence and slowing decisions when attention is most crucial. These factors combine quietly, but decisively. Unlike mountains, which may present dramatic cliffs or avalanches, caves exert their danger in ways that are less obvious, yet far more consistent. The risk is cumulative. Low oxygen drains strength before panic arrives. Rising water arrives without spectacle, carrying bodies along if escape is delayed. Confusion grows alongside fatigue, leaving explorers vulnerable in spaces where the environment exerts pressure without malice. Death in caves is rarely sudden or violent. It is often the result of subtle miscalculations against conditions that exist long before a single human arrives. Even experienced cavers acknowledge that deep systems demand respect beyond endurance or skill. Navigation, breathing, and energy must be managed in concert. Equipment may help, but it cannot fully overcome the rules of these passages. Lights illuminate only what is immediately near. Ropes and anchors assist, but cannot correct judgment errors. Every descent becomes a test of patience and awareness, as much psychological as physical. Life in caves persists with its own rhythm, independent of human presence. Stalactites and stalagmites grow imperceptibly. Mineral deposits form slowly on walls, and subterranean creatures move with subtle adaptations to darkness and limited oxygen. In such environments, the human body is an intruder, delicate and vulnerable, unable to match the endurance or adaptation of organisms evolved for shadows and stillness. For these reasons, deep caves claim more explorers than mountains do, not because they are dramatic or visible, but because they operate in quiet, unyielding ways. They measure time differently, demand continuous attention, and offer no immediate signals of danger. Each passage is a world unto itself, holding currents, air, and stone in balance, and requiring patience, care, and humility to traverse. In their depths, the earth reminds all who enter that isolation can be invisible, relentless, and profound, shaping survival through subtle, persistent pressures that few other places can match. Beyond the shaded forests and hidden depths, Earth stretches into open expanses where the horizon dissolves into heat and sand. The central Sahara rises as one of these vast spaces, a landscape defined less by obstacles than by absence. It is a place where distance itself becomes an instrument, shaping perception, judgment, and endurance. Here, the world appears infinite, yet it offers no guidance, no markers, no sense of familiarity beyond the shifting grains beneath the sun. Walking across this desert is to move through a rhythm of sameness. Sand ripples endlessly, forming ridges and dunes that rise and fall like gentle waves frozen in place. From one vantage point to the next, patterns repeat without distinction. Shadows stretch across slopes, then collapse into brightness, and the eye struggles to find reference points. Landmarks vanish into mirages, and even experienced travelers can lose sense of direction within moments. Distance is deceptive. Horizons recede as the body advances, offering a false promise of arrival. Navigation becomes a constant negotiation. Ancient stars can guide at night, but only when clouds permit. Wind shifts the sands, erasing footprints and smoothing dunes into uniformity. Modern instruments, if used, are subject to interference from heat and dust. Compass needles wobble subtly in strong magnetic anomalies, and GPS units can falter under the clear but searing sky. Every step demands awareness, every glance a careful measurement. Misjudgment can accumulate silently, leaving a path that winds in circles rather than forward. Water, scarce and precious, defines survival here more than terrain. Dehydration begins before fatigue arrives. The sun, relentless in its course, draws moisture from skin and clothing, leaving travelers lighter and slower without a clear signal of danger. Breathing becomes shallow, muscles tighten, and judgment dulls. Heat storage within the body grows perilous, even under shade or sparse shelter. Each decision, when to move, where to rest, how to ration supplies, carries immediate consequences. In the central Sahara, the desert shapes not only the body but the mind. The desert's ability to erase travelers is quiet, cumulative, and subtle. Unlike mountains that present visible danger or rivers that mark clear boundaries, sand and sun work together to disorient, to deplete, to dissolve human presence gradually. A person may walk for hours without realizing the distance they have truly covered. Paths become arbitrary, footprints vanish, and orientation is lost long before strength fails completely. Even the experienced guide, attuned to signs invisible to most, can feel uncertainty as the dunes shift and shimmer under heat. Life in this environment follows different rules. Sparse vegetation clings to ephemeral water. Camels and desert rodents navigate the sands with rhythms honed over generations. Insects and reptiles time their activity carefully, emerging only when conditions permit. The desert maintains balance through scarcity and adaptation, a quiet ecosystem that thrives in absence, yet offers little hospitality to those unprepared for its extremes. Isolation in the central Sahara is not imposed by walls or cliffs, but by the combination of monotony, distance, and relentless climate. Survival depends on preparation, awareness, and respect for the subtle pressures the landscape exerts. Travelers learn quickly that movement alone is not enough. Understanding how the environment shapes perception and endurance is essential. At dusk, the desert softens. Shadows stretch longer across dunes, and the temperature begins a slow decline. Winds whisper over sand, carrying the scent of distant rock and dry earth. The sky deepens to violet and then black, stars appearing in the clarity of minimal atmosphere. Even in this calm, the desert's lessons remain. It shapes travelers quietly, erasing certainty and reminding all who enter that distance without landmarks is more than measurement. It is a test of patience, perception, and the body's ability to endure, where the landscape itself dictates the pace of passage. In the central Sahara, the world is both vast and intimate, expansive and personal. It erases not with violence, but with persistence, teaching that isolation can be imposed simply by space, repetition, and the steady demand of sun and sand. The desert continues, indifferent and unchanging, a quiet boundary where human presence is always fragile. Above the peaks of mountains, beyond the clouds, and higher than the reach of weather systems, the atmosphere thins gradually, becoming a space where Earth's protective blanket begins to fade. The upper atmosphere stretches far beyond the clouds that drift lazily over landscapes below, a region of silence, cold, and near emptiness. It is a place that exists between the planet and the void, a boundary where life as humans know it cannot persist. Here, pressure decreases steadily. Each breath, taken closer to this altitude, delivers less oxygen than the last. The air grows thin, stretching and dispersing until there is simply not enough to sustain the body's most basic functions. Gases that support respiration are no longer dense enough to enter the lungs in quantities sufficient for life. The atmosphere becomes a quiet, invisible barrier, present but failing to nurture. Humans entering this region do not endure long. Without protective equipment, the body reacts almost instantly. Consciousness fades within seconds, the brain starved of oxygen before panic or thought can arrive. Muscles weaken, vision blurs, coordination vanishes as the nervous system slows in response to scarcity. The body collapses without struggle, a silent acknowledgement of limits defined by physics rather than fatigue. Temperature adds another layer of challenge. The upper atmosphere is not merely thin, it is cold, often dipping far below freezing. Heat escapes rapidly from exposed skin, blood vessels constrict, frost forms on surfaces within moments. The combination of low pressure and extreme cold transforms every movement into a delicate negotiation with the environment. Humans, fragile in comparison to these conditions, have no margin for error. Isolation in this region is profound. There is no shelter, no possibility of rescue within the time that life remains viable. Even in aircraft or high-altitude balloons, systems must function perfectly. Engines and oxygen supplies provide only a narrow window of safety. Outside these measures, survival is fleeting. The upper atmosphere does not merely challenge human endurance, it enforces absence through impossibility. The landscape below, Earth itself, becomes distant and abstract. Cities shrink to points, rivers appear as thin lines, and mountains vanish into scale and perspective. The planet curves subtly, revealing the horizon as a gentle arc rather than an endless line. From this height, isolation is not just physical, but conceptual. The world feels both vast and detached, a reminder that human presence occupies only a fragile layer near the surface. Within this realm, life is almost entirely absent. Microbes can exist within protective aerosols, and birds traverse lower sections of the upper atmosphere during migration, but continuous habitation is impossible. The environment provides energy neither in sunlight nor in warmth. Air is not thick enough to sustain combustion, not dense enough to carry the vibrations of sound efficiently. Even the faintest turbulence can disorient and destabilize. Exploration of the upper atmosphere requires precision, patience, and engineering designed to compensate for conditions that are fundamentally inhospitable. Capsules, pressurized suits, and life support systems are temporary shields against a space that does not accommodate biology designed for lower altitudes. Every ascent is carefully calculated, every second accounted for, as the margin between survival and collapse is measured in heartbeats rather than hours. Yet there is a quiet fascination in this isolation. From above, Earth appears serene and self-contained, a sphere of blue, white, and green floating in darkness. Storms, rivers, forests, and deserts continue without awareness of the presence above. The atmosphere, in its thin and fragile state, becomes a reminder of limits. It shows that even the planet has regions where human ambition cannot extend without aid, where existence itself is constrained by forces beyond reach. In the upper atmosphere, life exists only where adaptations allow, and human presence is provisional, fragile, and fleeting. Isolation here is not imposed by walls or distance, but by the very nature of air and pressure, reminding all who ascend that some places belong to Earth alone. The silence is complete, the expanse absolute, and the boundary between survival and impossibility immediate. Beneath the thin crust we walk upon, beneath oceans and continents alike, lies a realm that is both ancient and unyielding. The Earth's mantle stretches far below the surface, a layer of rock and molten material that hums with energy from the planet's interior. It is not a place of hills or rivers, of forests or deserts. It is a place where the rules of surface life no longer apply, where heat and pressure dominate with quiet certainty. Temperatures in the mantle exceed those of molten lava on the surface, rising steadily with depth. What begins as warmth soon becomes an intensity that softens rock and transforms mineral structures. Solid stone bends, flows, and even partially melts under conditions that humans cannot endure. There is no surface wind or cloud to mediate these extremes. Heat radiates silently from below, a slow but persistent force that reshapes every grain of rock it touches. Any human presence would be obliterated almost instantly, not by fire or eruption, but by the sheer energy of the environment. Pressure in the mantle adds another dimension to its inaccessibility. Rock is compressed by the weight of continents above, by the shifting oceans, and by the layers of stone that have accumulated over millions of years. This compression is not subtle. It reshapes matter at a molecular level. Crystals align differently, minerals deform, and even structures designed to resist force are flattened under the steady weight. A human body, designed for a thin layer of air and moderate pressures, would collapse immediately. Machinery fails similarly, unable to maintain shape or function under forces that exceed any surface measurement. Movement within this region is impossible. The mantle does not provide passages, corridors, or chambers. It is a continuous medium, dense and unbroken, flowing so slowly that continents drift atop it over eons. What seems solid is capable of plastic deformation, bending over thousands of years without fracture. Instruments sent to study the mantle from above provide indirect readings only, sensing vibrations, densities, and chemical compositions without ever penetrating its interior. The boundary is permanent because nothing alive and almost nothing constructed can endure it. Isolation in the mantle is not defined by distance or remoteness. It is defined by conditions themselves. Temperature and pressure act as barriers that cannot be engineered around. Even the most resilient materials cannot resist the forces for long. Even the most advanced protective suits, the strongest drills, the most precise instruments would fail. Here, isolation is absolute, imposed not by choice or accident, but by the fundamental physics of the planet. Science reaches into the mantle through observation, imagination, and careful modeling. Seismic waves, generated by earthquakes or controlled experiments, ripple through the earth and reveal the mantle's density, composition, and movement. Laboratory experiments recreate small sections under heat and pressure, providing glimpses into how minerals behave. Yet these glimpses are always indirect, and human presence remains impossible. The mantle is sensed, measured, and understood only from above. Despite its inaccessibility, the mantle is essential to life on the surface. It drives plate tectonics, moving continents, and forming mountains. It supplies heat to the crust, shaping volcanic activity and geothermal systems. Its slow convection carries chemical elements from deep within the Earth toward the surface, feeding cycles that influence oceans, soils, and the atmosphere. Life interacts with the mantle not by touch, but through consequence. The mantle's permanence is a reminder of limits. It is a place where curiosity cannot translate into presence, where exploration stops at observation, where the earth maintains a boundary that cannot be crossed. It exists quietly, vast and continuous, a world beneath the world we know, unreachable in its entirety, yet profoundly influential on every surface we inhabit. It is a boundary not imposed by walls, not drawn by humans, but carved by temperature, pressure, and time, enduring for billions of years and holding its secrets in silence. Far to the north, in the frozen reaches of Russia, humans once attempted to pierce the very crust of the earth itself. The Kola Superdeep borehole was not a journey across landscapes, nor a voyage into distant oceans. It was a deliberate descent straight down, into rock and time, a slender aperture that promised a view into layers untouched by our presence for hundreds of millions of years. The goal was simple in concept yet profound in ambition, to see how far the surface extended before it changed fundamentally, to measure what lay beneath the familiar soils and stones. The hole began as a narrow cylinder, its walls reinforced to maintain stability. Drills spun endlessly, cutting through layers of granite and sediment with a precision that seemed almost delicate given the scale of the task. Each meter gained was a step further into the planet's past, through strata that recorded epochs in mineral composition, pressure, and texture. The equipment moved steadily downward, guided by careful calculations and a human patience that measured months in days of drilling. Yet even in the controlled environment of the borehole, the Earth had its own intentions. As the drill descended, temperature readings climbed beyond expectations. The heat did not arrive gradually. It pressed upward from the depths, rising faster than models had predicted. Rock, long assumed to behave in predictable ways, began to soften, fracturing irregularly under stress. Drilling became difficult not from hardness alone, but from the response of stone to heat, as layers expanded, contracted, and warped subtly beneath the machinery. The deeper the drill went, the more evident it became that Earth was not a passive medium. Pressure from the overlying rock compounded with rising heat to create conditions that equipment could barely tolerate. Electronics became unreliable. Lubricants thickened. Metal components, cooled and hardened for earlier layers, began to bend unpredictably under stress. Even the most carefully designed systems struggled to cope. The planet, it seemed, was asserting its presence in ways both subtle and relentless, a reminder that human tools operate only within limits. This unexpected resistance was a lesson in scale and patience. The Kola borehole revealed that Earth's interior is active, not static. Heat from deeper layers rises along fractures and mineral veins, altering the mechanical properties of surrounding rock. Pressures accumulate slowly, but inevitably, deforming structures even before humans perceive the change. The deeper the hole, the more apparent it becomes that the surface's assumptions about hardness, temperature, and predictability cease to apply. Despite decades of effort, the borehole never reached the mantle. Its final depth, just over 12 kilometers, was remarkable in human terms, yet shallow in the scope of the planet. The drill had passed through hundreds of millions of years of rock, through chemical changes, folded layers, and ancient sediments, yet the Earth retained its ultimate secrecy. Conditions became impossible to endure, not through sudden catastrophe, but through cumulative, inexorable pressure and heat. Each meter gained demanded more attention, more care, and yet offered diminishing returns. The Kola Superdeep borehole stands as a testament to human curiosity and limitation. It is a record of ambition meeting environment, of precision meeting unpredictability. The hole itself is narrow, yet it speaks of vast forces. The rock surrounding it flows and bends slowly, silently reminding us that the planet has boundaries humans cannot cross by force or perseverance. In this experiment, the Earth pushed back not violently, but insistently, through heat, pressure, and deformation. It communicated a simple truth. Some parts of our world are meant only to be observed indirectly, their stories read through instruments and vibrations, never entered fully by human hands. The borehole remains a slender line into the deep past, a portal of knowledge constrained by the quiet, persistent power of the planet itself, where ambition meets the reality of an interior that refuses to yield. Far from the edges of continents and beyond the familiar currents of the Atlantic, Pacific, and Indian Oceans, the Southern Ocean unfolds in quiet expanses that stretch toward Antarctica. At first glance, the water appears endless, a dark expanse of rolling waves beneath a wide sky. Yet beneath its surface lies a rhythm shaped by extremes, a constant interplay of wind, cold, and motion that marks this ocean as the planet's most unforgiving sea. Here, the winds rarely pause. They sweep continuously around the circumpolar belt, driven by differences in temperature and pressure between the poles and the equator. Storms develop quickly and with little warning, gathering strength over vast distances. Waves rise and fall with an energy that seems infinite, colliding with one another in chaotic symmetry. Currents move in relentless patterns, spiraling and mixing, often carrying floating ice or debris at speeds that can outmatch the strongest vessels. Even experienced sailors speak of the Southern Ocean with quiet respect, acknowledging its ability to reshape journeys and expectations alike. The cold intensifies every challenge. Water temperatures hover just above freezing, denser and heavier than in more temperate seas. Exposure to this water, even briefly, triggers cold shock, a rapid physiological reaction. Breath comes in shallow, panicked gasps. Muscles seize. Circulation slows in an attempt to preserve core warmth. In moments, a body loses coordination, and survival depends on speed and preparation alone. The ocean does not pause to allow adjustment. Its conditions are immediate, demanding respect from the first contact with waves. Isolation here is absolute. The Southern Ocean surrounds Antarctica, with few safe harbors and limited opportunities for rescue. A vessel caught in storm or ice drift cannot rely on nearby ports or rapid support. Helicopters cannot land on open water, and even icebreakers are constrained by weather and sea conditions. Once trouble arises, there is no window large enough to guarantee survival, only narrow margins that depend on planning, experience, and a measure of luck. The ocean's violence is not dramatic in a singular moment, but cumulative. Waves do not need to capsize a ship to be dangerous. Repeated battering, waterlogged decks, and constant motion erode stability and energy. Crew fatigue builds steadily. Cold and dampness sap strength and judgment, and minor equipment failures can cascade into life-threatening situations. In this environment, endurance is measured not in distance covered, but in how long the body and vessel can remain functional under relentless conditions. Floating ice adds a quiet danger. Icebergs drift slowly yet unpredictably, portions hidden beneath the surface, reshaping navigation with every hour. Sea ice can appear solid and then fracture without warning, carrying weight that cannot be predicted. Even the smallest fragment becomes a hazard when combined with forceful currents and high winds. The Southern Ocean's hazards do not announce themselves clearly, yet they are persistent, inescapable, and cumulative. Despite this, life thrives here, adapted to extremes that humans cannot endure without protection. Seals slide gracefully across ice and water, penguins navigate waves with surprising dexterity, and plankton blooms occur in hidden niches when conditions allow. Energy flows through this ecosystem in ways invisible to human eyes, sustained by a balance of cold, wind, and motion that has existed for millennia. In such a place, human presence is always temporary. Voyages must be calculated precisely. Equipment, clothing, and provisions are designed to counteract both cold and instability. Every moment carries risk. Even in modern vessels with advanced technology, the margin for error is narrow, and the ocean does not yield to inexperience or delay. The Southern Ocean remains a domain defined by its own rules. Its seas move with intent, cold penetrates with immediacy, and rescue is rarely possible once danger arises. Here, isolation is imposed not by distance alone, but by the combination of force, temperature, and remoteness. It is a place where humans can enter briefly, but only with vigilance and respect, and where the planet itself enforces its boundaries with quiet, relentless certainty. Far above the valleys and rivers of Asia, the Tibetan Plateau stretches like a pale ocean of stone and wind, an elevated expanse where Earth seems to touch the sky. Its mountains rise in quiet sequences, peaks and ridges punctuating horizons that extend for hundreds of kilometers. Unlike deserts or oceans, the plateau's isolation is not sudden. It grows gradually, measured in altitude rather than distance, shaping the body and mind through a slow, persistent pressure that is invisible yet unavoidable. Air thins steadily as elevation increases. At the base, oxygen is abundant, life unfolds as usual, and the body functions without conscious effort. But higher, every breath delivers less than the one before. The lungs strain to extract sufficient oxygen, while the heart and blood work harder to carry it to tissues that are suddenly starved. This shortage is not catastrophic at first. It is cumulative, a subtle depletion that becomes more pronounced with each day, each step along the rugged terrain. Travelers notice fatigue creeping earlier, muscles tightening more quickly, coordination faltering with simple movements. The biological strain imposed by this chronic oxygen deprivation affects every system. Red blood cells multiply to compensate, thickening the blood. Heart rate increases. Metabolism shifts in response to limited energy availability. Sleep becomes lighter, rest less restorative. Even cognition is affected, as the brain receives less oxygen than it requires for optimal function. All of these changes are gradual, imperceptible to most at first, yet inexorably altering how the body functions in this high world. Isolation on the Tibetan Plateau is slow and measured. It is not marked by immediate danger, sudden cold, or crushing pressure. Instead, the landscape enforces separation through endurance. Trails grow longer, winds harsher, and exposure to altitude compounds with distance. Small communities exist, adapted over generations to thrive in these conditions. Yet beyond these settlements, human presence diminishes naturally. Travelers unacclimated to the heights experience fatigue, disorientation, and physiological stress that slowly discourages prolonged exploration. The environment also contributes subtly to isolation. Temperatures fluctuate sharply between day and night, and UV radiation intensifies with elevation. Snowfields and rocky ridges create both barriers and corridors, directing movement in ways that are not immediately obvious. Storms can appear quickly, clouds rolling across peaks, reducing visibility and altering paths. Streams run cold and swift, fed by melting glaciers. Each feature combines with oxygen deprivation to create a cumulative challenge, one that slowly narrows the margin for human presence. Despite the strain, life on the plateau adapts. Yak graze on sparse grasslands, their lungs and circulatory systems finely tuned to low oxygen. Wildflowers bloom briefly in sheltered valleys. Birds navigate thermals and winds, finding routes between cliffs that are invisible to human eyes. The plateau's ecological systems operate at high efficiency, shaped by long-term adaptation to altitude and season. Humans, in contrast, must rely on acclimatization, careful pacing, and constant attention to the limits imposed by the air itself. In this way, isolation on the Tibetan Plateau is measured in increments. Each meter gained subtly, changing how the body interacts with the world. Mountains appear closer as obstacles, yet the true boundary is physiological. Travelers retreat not because the land forbids them, but because the air itself cannot sustain prolonged activity. Even modern technology, oxygen tanks, heated clothing, and specialized vehicles cannot remove the slow pressure of altitude entirely. Here, isolation is patient. It arrives quietly, nudging endurance to its limits. It asks respect for both body and environment, rewarding attention and preparation while discouraging intrusion. The Tibetan Plateau is vast, high, and unyielding not through force, but through the invisible, cumulative weight of air itself, a quiet boundary measured in oxygen, metabolism, and the steady, unrelenting passage of time. Deep within the vast weave of South America, beyond the flowing rivers and familiar settlements, the Amazon stretches into spaces that few have seen and even fewer have touched. These uncontacted regions are not defined by distance alone. They exist as quiet worlds preserved by isolation, where every tree, vine, and stream is part of a system that has endured for centuries without interruption. Here, the forest carries a rhythm entirely its own, guided by life that has adapted to thrive far from human interference. The isolation of these regions is not merely geographic. Pathogens, microscopic agents that circulate unnoticed in human populations, pose a silent but powerful barrier. The people who live in these forests, having never been exposed to common illnesses from the outside world, remain exceptionally vulnerable. A single virus or bacterial infection could spread rapidly, with consequences that are immediate and severe. This biological reality enforces separation as strongly as any river or mountain range. The forest itself becomes a guardian, maintaining boundaries through a delicate balance of exposure and protection. The ecosystems here are equally fragile. Trees rise in dense, layered canopies, creating microclimates that support countless species of insects, birds, and mammals. Each organism occupies a specific niche, interacting with its environment and neighbors in ways that are subtle and precise. A small disruption, a cleared patch of forest, an introduced species, or even temporary human presence can ripple outward, altering soil composition, water flow, or predator-prey relationships. Life in these uncontacted areas depends on continuity, and continuity depends on absence. Isolation is the thread that holds the system together, woven slowly over generations of undisturbed growth. Rivers wind through these spaces with gentle persistence, carrying nutrients and shaping terrain without artificial influence. Wildlife moves in patterns dictated by food, season, and instinct. Birds call and respond in echoes that travel through the layers of leaves, while mammals navigate undergrowth with awareness honed over lifetimes. Every step within the forest, every pulse of wind, contributes to a balance that has developed far longer than any human presence. Isolation in the Amazon is maintained actively by the inhabitants themselves. Uncontacted groups live with knowledge accumulated over generations, understanding how to navigate, hunt, and build without disrupting the delicate ecosystems around them. Their pathways, camps, and practices are designed for sustainability, ensuring that food sources remain abundant and forests continue their quiet cycles. Their separation from the outside world is not just preference but necessity, a form of survival enforced by both the forest and the vulnerabilities of the people themselves. The boundaries of these regions are subtle yet precise. Villages may remain hidden behind dense vegetation, rivers, or terrain that is difficult to cross. Even attempts at observation are challenging, as sounds and movements dissipate quickly among the trees. From above, satellite images may reveal outlines of clearings or river paths, but the life within remains largely invisible, untouched by external influence. Here, human presence is fleeting, temporary, and often unintentional. Researchers and explorers know that the act of entering can carry irreversible consequences. Pathogens introduced from the outside, even accidentally, can spread with devastating effect. Equipment, clothing, and even movement disturb the soil, water, and vegetation. The forest systems, adapted to quiet persistence, are vulnerable to intrusion, and respect for these boundaries is essential to preserving life. In the uncontacted regions of the Amazon, isolation is both protector and necessity. It allows ecosystems to function in balance, species to thrive in intricate harmony, and human populations to survive without exposure to external threats. These places exist quietly, maintained over centuries, a living testament to the power of absence, where the forest and its inhabitants continue uninterrupted, secure in a boundary enforced by both biology and the wisdom of those who call it home. Across the many edges of the world we have explored, from frozen plateaus to crushing ocean depths, from scorching deserts to forests untouched by human hands, one principle emerges quietly. Access is measured not only by distance or geography, but by the possibility of help. This is the lesson of rescue, a concept that shapes where humans can be safely present and where the world remains off limits. In familiar emergencies, the notion of a golden hour often guides response. Within 60 minutes of an accident, medical intervention can mean the difference between life and death. Beyond that threshold, survival becomes precarious. This simple idea scales upward to extreme environments, where the margin for rescue defines the limits of human activity. On the icy expanse of Antarctica, for example, a storm can isolate a research station in hours. Helicopters cannot land, satellites provide guidance but no warmth, and fuel may freeze in moments. The golden hour in these conditions is compressed, almost imperceptible, leaving presence precarious. Even in less obviously extreme environments, the constraints of time dominate. In the depths of the Mariana Trench, a malfunction of a submersible cannot be remedied by distant support. The ascent itself may take hours under pressure, while the craft's systems hold only a finite reserve. On the Tibetan Plateau, a climber experiencing oxygen deprivation cannot be reached in time if conditions worsen rapidly. The landscape's vastness is not the only barrier help cannot arrive fast enough. In these cases, the world's isolation is not defined by kilometers, but by the interval between emergency and intervention. Isolation as time, rather than space, reframes our understanding of boundaries. A desert may seem empty, because it stretches for hundreds of kilometers. But a traveler's vulnerability depends on the rate at which dehydration or heat exposure develops. A cave may feel enclosed by stone, yet it is the minutes spent without oxygen that define its danger. Ice and pressure, chemical hazards, storms, and altitude all transform ordinary spaces into areas of extreme temporal risk. Presence in these regions is always a negotiation with time. Every second counts, and each movement carries cumulative consequences. Rescue defines access because it determines the feasibility of survival. Equipment, supplies, and planning extend the window, yet they cannot eliminate it entirely. A well-prepared expedition may reach a mountain pass or dive to a trench, but the environment remains indifferent to schedules, readiness, or expectation. Every journey depends on a buffer of time, how long humans can endure without immediate aid. Where that buffer closes, the boundary becomes absolute. Technology may extend reach, but it does not eliminate the temporal constraints that govern survival. This perspective changes how we perceive isolation in extreme environments. It is no longer merely a function of distance or difficulty, but a reflection of the human body's limits and the capacity of support systems. A place may appear approachable from maps, satellites, or instruments, yet if aid cannot arrive within the time required for survival, access is denied. Isolation is measured in minutes, hours, or days, time dictated by nature, not by arbitrary markers or political borders. In practical terms, understanding isolation as time emphasizes preparation, observation, and humility. It reminds explorers and scientists that even when geography seems navigable, the invisible clock of survival governs all activity. Equipment must function reliably, systems must be redundant, and every movement must account for the limits imposed by the environment. Presence becomes contingent, fleeting, and profoundly respectful of forces beyond control. Ultimately, rescue defines access in the quietest yet most absolute way. Mountains, oceans, ice sheets, and deserts do not merely exist as physical barriers, they establish temporal boundaries that cannot be ignored. Where help cannot arrive in time, the world enforces its limits. Distance may matter, but the true measure of isolation is the time available to survive, a rhythm dictated not by human ambition, but by the patient, unyielding pace of the planet itself. In the quiet corners of our world, where isolation stretches uninterrupted, the human brain responds in ways both subtle and profound. When the body is separated from familiar stimuli, light, sound, touch, and social cues, perception itself begins to shift. Sensory deprivation in these extreme spaces does not arrive abruptly. It creeps in gradually, carried by silence, monotony, and the absence of ordinary markers of time and place. A single sensation becomes magnified, then repeated, until the mind begins to question what is real and what exists only within thought. Dark caves, deep oceans, or polar interiors create an environment in which senses are stretched to their limits. Light fades or disappears entirely, leaving the eyes without reference points. Sounds are muted or distorted by layers of water, ice, or stone. Touch offers only the immediate surfaces beneath fingers or feet. In these conditions, the brain must compensate, drawing patterns and meaning from what little it receives. Shadows become shapes, echoes become voices, and the passage of time loses its ordinary rhythm. What begins as a simple adjustment to sensory scarcity can become a cascade of subtle illusions and distortions. Time itself begins to lose coherence. Minutes stretch and contract unpredictably, marked not by clocks but by perception of effort, breath, and internal rhythms. In extreme cold, heat, or pressure, a single task may feel endless. In darkness or monotony, hours can collapse into an instant, or a moment can feel prolonged beyond reason. The mind, deprived of familiar environmental cues, struggles to anchor experience. Sleep patterns shift unpredictably. Dreams intrude into waking thoughts. Days blur together, and the boundary between reality and imagination softens. Prolonged isolation can lead to psychological strain that accumulates imperceptibly at first, then grows into a form of collapse. Anxiety and disorientation emerge naturally as the mind attempts to reconcile internal perception with external absence. Attention falters, memory becomes unreliable, and decision making slows. In environments where survival depends on constant awareness, these changes are more than uncomfortable, they are dangerous. Explorers and scientists operating in extreme conditions report feelings of unreality, fleeting hallucinations, and sudden lapses in judgment, each a subtle reminder that the mind is as fragile as the body under sustained isolation. The brain's response is not uniform. Individuals vary in their tolerance, yet even the most resilient experience shifts when isolation exceeds thresholds of duration or intensity. Communication, when possible, becomes vital. Interaction with others, or even brief signals of presence from equipment, can re-anchor perception and slow the drift into disorientation. In complete absence, however, the mind is left to construct its own patterns, which may align with reality or diverge entirely. Isolation also alters emotional states. Calm landscapes can feel oppressive, silence can become deafening. The absence of routine and social interaction reduces feedback that normally regulates mood and focus. Feelings of loneliness, unease, or even panic can emerge spontaneously, amplified by the quiet, persistent pressure of the environment. The brain, deprived of its usual network of signals, begins to respond internally, creating emotional landscapes as vivid as the physical world surrounding it. Yet, within this challenge lies insight. Studying the brain in isolation teaches us how closely human experience is tied to context, rhythm, and sensory input. It reveals the ways in which perception, cognition, and emotion are interwoven, and how quickly they can unravel when familiar anchors are removed. The phenomenon is a reminder that isolation is not simply a physical state, it is a force that operates directly on the mind. In extreme environments, where survival may already be precarious, sensory deprivation and temporal distortion combine to impose a boundary as absolute as any ice shelf or ocean trench. The human brain, finely tuned to light, sound, and social cues, becomes a measure of limits. Without input, without rhythm, without companionship, perception falters, time stretches, and the mind itself becomes part of the landscape that is unreachable, unyielding, and utterly separate from ordinary life. In many corners of the earth, isolation is not simply a challenge or a limitation. It can also be a quiet form of protection, preserving delicate systems that would otherwise be vulnerable to intrusion. Fragile ecosystems, shaped over millennia, depend on continuity, balance, and the absence of interference. In these spaces, life continues, not because conditions are easy, but because humans are not present to alter the subtle rhythms that sustain it. Forests, wetlands, and coral reefs often provide the clearest examples. Each plant and animal occupies a specific niche, interacting in ways that are both complex and precise. Insects pollinate certain flowers, while birds disperse seeds in patterns that maintain the structure of the forest. Streams carry nutrients, supporting fish that feed on tiny organisms, which in turn support larger predators. The entire system functions as a web, resilient when undisturbed, yet highly sensitive to changes in temperature, water, or species composition. Even a small human footprint, a path cut through vegetation, the removal of a single species, or the introduction of an alien plant can ripple across the ecosystem in unforeseen ways. In oceans, isolation has similar effects. Coral reefs, often described as rainforests of the sea, are highly sensitive to shifts in light, temperature, and chemical composition. Overfishing, pollution, or even brief human visitation can disrupt these reefs. When regions remain untouched, the intricate relationships between corals, fish, invertebrates, and microorganisms continue undisturbed. Spawning cycles proceed, symbiotic relationships endure, and the reef maintains its balance. Isolation, in this context, is a protective layer, allowing processes to unfold without interruption. Human disruption extends beyond physical interference. Noise, light, and chemical traces all influence behavior in subtle ways. Migratory animals may change routes in response to human presence. Soil and water chemistry can be altered by pollutants, fertilizers, or runoff. In areas where humans intrude, species may retreat or decline even when the impact is not immediately visible. By contrast, regions with limited access or deliberate protection remain refuges, allowing ecosystems to operate under their own rules, uninterrupted and self-regulating. Absence, then, becomes a form of preservation. Islands left untouched, deep caves unvisited, and regions isolated by harsh climates serve as natural reserves. Life adapts to these spaces in ways that are independent of human influence. Predators and prey interact freely. Plants grow according to cycles dictated by light, water, and soil. Microbial communities thrive, evolving in isolation over millennia. In each instance, the absence of humans maintains stability, allowing life to persist despite environmental extremes that would challenge the same species elsewhere. This protective isolation is often delicate. It requires recognition of limits, respect for boundaries, and awareness that presence itself can alter dynamics. Scientific studies of untouched regions reveal the intricate patterns that emerge when life operates without interference. Ecosystems demonstrate resilience and adaptation, providing insights into evolutionary processes and natural cycles. In essence, some of the most extraordinary life on Earth owes its survival not to shelter, abundance, or luck, but to the simple fact that humans are absent. Isolation, whether imposed by geography, climate, or deliberate protection, allows ecosystems to function as they have for generations. It preserves complexity, nurtures adaptation, and offers a window into a world that continues largely on its own terms. Here, absence is not emptiness. It is a quiet force of conservation, a subtle, enduring guardian for life that has learned to flourish without attention, yet cannot survive sustained disruption. In some corners of the world, isolation is not a natural force but a consequence of human activity. It arrives slowly, imposed by choices, accidents, and unintended consequences. Places that might once have been part of thriving ecosystems or inhabited landscapes can become off limits, not because of distance, cold, or pressure, but because humans have altered the environment in ways that make it inhospitable. Here, absence is no longer a gentle guardian. It is enforced by the very presence and impact of human civilization. Radiation offers one of the most stark examples. When accidents occur at nuclear facilities, or when weapons testing leaves long lasting residues, regions can become dangerous for human habitation for decades, even centuries. Radiation is invisible, pervasive, and persistent. It moves through air, water, and soil, accumulating in ways that are often unpredictable. Access becomes limited, not through natural barriers, but through the invisible hazard that threatens biological systems at a molecular level. Plants, animals, and microorganisms may continue to survive, yet humans must remain distant, prevented from entry for safety. In these places, isolation is imposed by the invisible consequences of technology and energy. Pollution, in its many forms, also creates enforced separation. Industrial runoff, chemical spills, and persistent plastics accumulate in ecosystems, changing the composition of soil, rivers, and oceans. Contaminated water can make survival impossible for humans and many other species, while airborne toxins travel far beyond their point of origin. Areas near heavy industrial centers, abandoned mines, or chemical storage sites may become unusable for habitation or even casual exploration. The environment itself, altered by chemicals introduced by humans, dictates where life can safely exist and where it cannot. The absence of humans becomes not a matter of choice, but a necessity imposed by the transformed landscape. Climate damage represents a slower, yet equally powerful, form of isolation. Rising temperatures, shifting rainfall patterns, and extreme weather events can render regions inhospitable over years or decades. Coral reefs bleach and die, low-lying islands flood regularly, and forests may experience droughts or fires that prevent human activity. In these situations, isolation is imposed gradually as conditions change beyond the limits that humans or even traditional agriculture can endure. The world itself becomes a selective force, separating people from areas that were once accessible as ecosystems transform under pressures generated largely by human influence. These human-created boundaries often overlap with natural limits, creating compounded challenges. A forest damaged by pollution or altered rainfall may become fragile in ways that amplify isolation as disease, invasive species, or soil degradation further reduce viability. Rivers and lakes may shrink, soil may become infertile, and exposure to toxins or heat can make survival tenuous. In these cases, human-caused isolation is both direct and indirect, shaping landscapes and ecosystems through multiple interacting pressures. Yet, even in these altered places, life persists. Plants adapt to new soil chemistry, microorganisms evolve to tolerate contaminants, and some animal species exploit niches created by human impact. These regions become unintended experiments, illustrating resilience and adaptation even as they remain inaccessible or hazardous to people. When isolation is caused by humans, the absence of people is enforced by risk rather than choice, by altered chemistry rather than geography, by heat, contamination, or radiation rather than distance. These are spaces where life continues cautiously, constrained by the legacies of human activity, and where our influence dictates both presence and absence. Here, isolation is a reminder that even the most mobile and resourceful species on Earth can encounter boundaries set not by the planet itself, but by its inhabitants, leaving regions to endure quietly, protected only by our inability to enter safely. Human curiosity has always sought to extend beyond limits. We build machines to climb mountains, submerge into oceans, drill through rock, and ascend into the skies. Technology allows us to push farther than our bodies alone could reach, to survive in environments that would otherwise be fatal. Yet even the most advanced tools are not limitless. In the quiet corners of extreme environments, nature asserts boundaries that no invention can fully overcome. Adaptation through technology is not guaranteed. Every device has constraints defined by materials, energy, and the laws of physics. In the icy interior of Antarctica, for example, fuel thickens and batteries lose efficiency under persistent cold. Drills designed for rock may seize when metals contract or lubricants freeze. Submersibles descend into the crushing depths of ocean trenches, yet pressure eventually exceeds hull strength, forcing retreats. In each case, human ingenuity meets a wall defined by the environment itself, a reminder that survival depends on more than design, it depends on conditions that cannot always be controlled. Even in seemingly stable locations, limits emerge unexpectedly. Electronics fail when humidity condenses in enclosed compartments. Heat builds in machinery that is meant to endure cold. Corrosion occurs faster than anticipated, slowly compromising critical systems. The lesson is subtle but clear. Tools amplify human capability, yet they cannot replace the adaptive resilience built into life itself. Nature defines parameters, and when those parameters are exceeded, adaptation falters. These constraints are not abstract, they are measured in moments, minutes, and materials. The golden hour in remote landscapes is as much about machine performance as human endurance. A miscalculation in power supply or structural integrity can make the difference between success and retreat. In caves and deep-sea environments, technology extends observation, yet it cannot prevent oxygen depletion, cold shock, or crushing pressure from exerting influence. Machines allow exploration, but they do not remove fundamental limits imposed by the planet. Nature's boundaries operate in multiple dimensions. Temperature, pressure, chemical composition, and structural integrity all interact to create conditions that resist manipulation. On high plateaus, oxygen scarcity challenges even pressurized suits. In volcanic regions, molten rock and toxic gases overwhelm protective materials. In the deep ocean, water density and chemical composition push vessels to their design limits. Each environment reminds us that the planet is not a passive stage, it is an active force with properties that demand respect and recognition. Even advanced technology cannot guarantee long-term adaptation. Life evolves over millennia, finely tuned to local conditions. Humans and their machines operate on time frames of hours, days, or years. Equipment cannot replicate the resilience of extremophiles that thrive in crushing pressure, near freezing temperatures, or toxic environments. Survival depends on understanding limits, working within them, and retreating when the environment exceeds capability. Technology amplifies potential, but it also reveals boundaries. Every measurement, dive, ascent, or drilling operation demonstrates that nature cannot be fully tamed or circumvented. Limits are not failures. They are indicators of the planet's persistent power, subtle yet absolute. In these extremes, adaptation is contingent, temporary, and fragile. Machines allow glimpses, but they cannot create permanence where conditions are inherently hostile. In the quiet, extreme corners of Earth, these lessons are clear. Nature defines its own rules, and no matter how advanced our technology, those rules remain. Boundaries exist not to restrict curiosity, but to mark the interface between human reach and planetary force. Machines may extend exploration, but they cannot override the fundamental realities of temperature, pressure, chemistry, or time. In these spaces, technology demonstrates both our capability and our limitations, showing that adaptation is never guaranteed and that the planet itself ultimately sets the terms of access and survival. From the summits of mountains to the depths of oceans, from deserts baked under relentless sun to the frozen interiors of polar continents, the Earth presents a surface that is as varied as it is demanding. Yet, despite its vastness, humans inhabit only a thin, fragile layer of it. Our cities, farms, and settlements cling to zones where air, temperature, and water allow life to persist comfortably. Beyond this narrow band, the planet quickly shifts to conditions that are inhospitable, even lethal. In this way, humanity lives atop a narrow veneer, surrounded by environments that remain largely uninhabitable. The atmosphere itself is a defining factor. We require oxygen at precise concentrations and pressures. Step too high into mountains or too far above the surface, and the air becomes thin, leaving the lungs starved and the body vulnerable. Descend into the deep ocean, and pressure mounts to levels that crush steel and deform the human body. Beyond the thin layer where our physiology is effective, the world becomes a domain we cannot endure. Even with technology, survival is provisional, dependent on equipment, energy, and timing. The planet's extremes define the limits of presence. Temperature is another boundary. Hot deserts, scalding volcanic flows, frozen polar plains, and high-altitude plateaus all exceed the tolerances of the human body. Heat and cold move beyond discomfort into fatality within hours, minutes, or even seconds. Shelters and protective clothing can extend limits, yet they cannot fully substitute for the narrow conditions in which human biology thrives. Survival here depends less on choice than on the environmental parameters that dictate where life can exist. Water and chemistry reinforce this thin band. Some areas are too dry to sustain vegetation or animals, while others carry toxins or salinity that prevent long-term habitation. Rivers may vanish into sand or flow unpredictably. Soils may be infertile or contaminated. Even seemingly mild regions can contain microenvironments where resources are insufficient. Humanity's footprint is defined by these constraints, a continuous negotiation with the small portion of the planet capable of supporting life comfortably. Hostility is the default state of the Earth. Storms rise suddenly, ice forms where warmth is absent, winds strip moisture from skin, and soil erodes under the weight of rain or drought. Predators, pathogens, and natural hazards operate without regard for human presence. The landscapes beyond our settlements exist largely independent of human influence, governed by forces that are constant, patient, and absolute. In these regions, survival is an exception rather than the rule, and life continues only through adaptation honed over millennia. Even within habitable zones, the environment retains its power. Floods, fires, droughts, earthquakes, and storms remind us that comfort is conditional, that the thin layer we occupy is always bordered by risk. Technology and planning mitigate danger, but they do not eliminate it. The Earth maintains thresholds that demand respect, and in the vast majority of the planet, humans remain unable to persist without careful preparation and constant vigilance. From the perspective of the wider planet, humans are rare occupants. Our cities and farms cover only a fraction of continents. Most of the surface remains a domain of extremes, where adaptation is the privilege of specialized species. Here, ice flows, molten rock, crushing depths, and arid plains persist, largely untouched and indifferent. Life thrives in these regions, when it is suited to the conditions, but the human form requires a narrow, fragile band of climate, chemistry, and stability. In this sense, Earth is mostly uninhabitable. The layer we occupy is slender, our presence temporary, and our survival conditional. Beyond that, hostility is the default state, expressed through heat, cold, pressure, chemical extremes, and environmental unpredictability. Humanity exists atop the planet's surface as a delicate veneer, a small presence amidst a vast, untamed world that continues in rhythms and forces we can observe, measure, and admire, yet cannot fully command. Far from cities and farms, beyond forests and oceans touched by human hands, there are places on Earth where life exists under conditions that seem impossible. In these corners, isolation has shaped survival in ways that reveal the resilience, creativity, and persistence of life itself. Extremophiles organisms that thrive in heat, pressure, acidity, or darkness offer the most vivid example of how life adapts when conventional resources are scarce. They are small, often invisible to the eye, yet they endure, reproducing and evolving in environments that would quickly overwhelm humans or familiar species. In deep sea hydrothermal vents, for instance, water seeps through cracks in the ocean floor, superheated by Earth's interior and rich in minerals. Sunlight never reaches these depths, yet microbial communities flourish, feeding on chemicals and energy supplied by the vent itself. Tube worms, clams, and crustaceans gather around these vents, forming complex ecosystems entirely independent of photosynthesis. Here, survival does not rely on the sun, but on chemical energy harnessed in novel ways. Life demonstrates flexibility and resourcefulness, showing that even in the absence of light, organisms can establish thriving communities. Isolation in extreme environments also illuminates the origins of life. Some scientists suggest that life may have begun in similarly extreme settings, hot, chemically active regions beneath the surface or at the bottom of oceans, far from sunlight. Studying extremophiles provides clues to the earliest forms of life, revealing metabolic strategies that may have sustained organisms billions of years ago. Life is revealed as persistent and adaptable, capable of forming in conditions that seem at first inhospitable and surviving through mechanisms that continue to operate today. Beyond the deep sea, extremophiles exist in deserts baked under the sun, in frozen glaciers, in acidic lakes, and in underground rock formations. Each habitat teaches a different lesson. In Antarctic subglacial lakes, microbes persist in water that has been cut off from the atmosphere for millions of years. In boiling hot springs, bacteria metabolize sulfur and other minerals at temperatures exceeding the boiling point of water. Isolation fosters these adaptations, allowing life to explore niches that are closed to most other organisms. Without competition or interference, organisms refine strategies that are highly specialized, resilient, and astonishingly efficient. Observing these isolated forms of life also teaches us about the limits and possibilities of survival. It demonstrates that life is not confined to what is familiar, nor restricted to light, warmth, or moderate pressure. Organisms persist where humans cannot, reminding us that our perception of habitable conditions is limited. Isolation is not merely absence, it is a crucible in which life discovers new methods of sustaining itself, evolving, and thriving. These lessons extend beyond biology. They speak to the resilience of systems, the importance of stability and continuity, and the capacity of life to persist under extreme constraints. In every extremophile, in every isolated ecosystem, there is a quiet testimony to the ingenuity of evolution. Life adapts not by choice, but by necessity, finding pathways to persist where others fail. Isolation, then, is both a teacher and a protector. It preserves environments in which life can experiment, evolve, and endure. By studying these secluded realms, we learn not only how organisms survive without sunlight, or in crushing pressure, or in boiling waters, but also how life itself is defined by adaptability, persistence, and the capacity to thrive against conditions that seem impossible. In these remote places, the earth whispers a profound lesson. Life is more flexible, inventive, and enduring than we often imagine, and even in darkness, even in extremity, it finds a way to continue. Exploration has always been part of human curiosity. We measure, map, and observe, seeking to know every corner of the earth and beyond. Yet, in the quiet, untouched places of the planet, a different kind of understanding emerges. One that does not require footsteps or instruments, but respect, patience, and restraint. Not everything is meant to be explored, and in some cases, the very act of intrusion carries consequences that cannot be undone. Scientific ethics guides the choices of researchers who approach these delicate spaces. The impulse to discover must be balanced against the responsibility to preserve. Every environment, from the frozen depths of Antarctic lakes to uncontacted forests of the Amazon, exists in a fragile equilibrium. Introducing humans, even briefly, can alter microbial communities, disturb animal behavior, and shift chemical balances in ways that may never fully recover. Ethical practice recognizes that observation does not always require presence, and that some experiments are better conducted from a distance, using remote sensing, modeling, or non-invasive sampling. The cost of intrusion is subtle at first, then cumulative. A single footprint in a remote wetland may trample mosses that took decades to grow. A drone or boat passing over a nesting site may scare away birds, disrupt feeding patterns, or attract predators. Equipment, clothing, and even the microbes carried unknowingly by explorers can introduce elements that native species have never encountered. These small disruptions accumulate over time, sometimes imperceptibly, reshaping ecosystems that have evolved in isolation. In these circumstances, the act of exploration is inseparable from its impact, and curiosity must be tempered by foresight. Ethics in exploration also considers the long-term effects on human communities. In regions inhabited by uncontacted peoples, for example, even a brief visit can introduce diseases that spread rapidly through populations without immunity. Respecting isolation is a form of protection, acknowledging that some knowledge cannot be gained without risk to life itself. The cost of intrusion is measured not only in environmental impact, but in the potential for harm to those who depend on these spaces for survival. Scientific progress does not require the absence of boundaries. In fact, some of the most profound discoveries come from indirect observation. Remote cameras, environmental DNA, satellite imaging, and acoustic monitoring allow researchers to study ecosystems without physical intrusion. These techniques respect the autonomy of the environment, revealing patterns, behaviors, and processes without altering the systems themselves. In doing so, science honors the principle that observation and understanding can coexist with preservation. Choosing not to explore is itself an ethical decision. It reflects an understanding that the value of a place is not measured solely by human knowledge, but by the integrity of its processes, the stability of its communities, and the continuity of life within it. Some regions retain their vitality precisely because they have been left alone, and their resilience offers lessons that cannot be captured through direct interaction alone. In the quiet corners of Earth, restraint becomes a form of stewardship. It acknowledges that our curiosity, while natural, has limits defined by consequence. Not every cave needs to be entered. Not every lake needs to be drilled. Not every forest measured by footsteps. Some knowledge is best gained through patience, observation, and respect for the boundaries that exist for reasons we may never fully understand. In these untouched spaces, the cost of intrusion reminds us that science is not only about discovery, but also about care, humility, and recognition that sometimes the most responsible action is to leave a place undisturbed. Across the earth, beyond the reach of cities and roads, there are places where life continues quietly, without human interference. In these spaces, the rhythms of nature unfold on their own, guided by forces older than our presence. Forests, wetlands, rivers, and oceans operate in subtle, intricate patterns, sustained by cycles of energy, growth, and decay that have persisted for millennia. Here, the power of absence becomes evident. Life can flourish and systems can remain stable precisely because humans are not part of the equation. In dense forests, for example, trees grow, shed leaves, and recycle nutrients without interruption. Insects pollinate flowers and disperse seeds, maintaining plant diversity across the canopy. Predators and prey maintain population balances naturally, each adjusting to the presence of the other with timing and precision honed over generations. Water flows along streams and rivers, carving channels, depositing sediment, and supporting aquatic life, all without deliberate human direction. In these areas, systems function according to their own rules, often more efficiently than they do in areas influenced by people. Isolation allows stability to emerge. When humans are absent, disturbances are rare, and the processes of succession and regeneration proceed without interruption. Forests that are left alone for decades can recover from storms or fires more fully than those repeatedly accessed or modified by people. Wetlands that are untouched maintain water quality, support migratory birds, and store carbon, all without management or oversight. Absence reduces the introduction of pollutants, invasive species, and other factors that can destabilize ecosystems. In this way, the quiet presence of untouched spaces contributes to resilience, allowing life to adapt and maintain balance over long periods. Oceans, too, display this principle. In areas far from fishing, shipping, and development, coral reefs, seagrass beds, and pelagic ecosystems continue their cycles uninterrupted. Fish, plankton, and marine mammals interact in patterns shaped by evolution rather than human need. Migratory routes remain predictable, food webs remain intact, and breeding grounds function without disruption. The absence of humans creates a buffer, a space where natural processes can unfold in full complexity, offering a contrast to regions heavily influenced by human activity. Even in extreme environments, such as polar interiors, deep oceans, or high mountains, absence reinforces stability. These systems endure because they are largely untouched. Microbial communities in subglacial lakes, for example, operate in a delicate balance of chemical gradients and energy flows. Life in hydrothermal vents relies entirely on chemical energy rather than sunlight. Each organism occupies a niche refined over millennia, and each system maintains equilibrium without human intervention. The quiet power of absence reminds us that presence is not always beneficial. While human observation and management can be valuable, it is the lack of interference that allows many systems to function optimally. Isolation preserves complexity, maintains relationships between species, and sustains processes that are invisible but essential. Life often thrives best when left alone, guided only by natural cycles and forces. In the spaces where humans do not intrude, stability is a gift of time and continuity. Systems evolve, recover, and adapt without external pressure, demonstrating resilience that is often lost in heavily influenced landscapes. The quiet power of absence is a form of stewardship written by the planet itself. It shows that sometimes the most important intervention is restraint, and that some of the most enduring and intricate systems rely not on our touch, but on our distance. Here, life continues in its own rhythm, and the earth quietly maintains its balance, unobserved and uninterrupted, a testament to the enduring strength of isolation. As we reach the quiet edges of our exploration, it becomes clear that the story of Earth is not centered on human presence. From icy plateaus to deep oceans, from deserts to uncontacted forests, the planet unfolds according to rhythms and forces that have existed long before us and will persist long after. Life, landscapes, and systems operate in ways that are independent of human intention, often remarkably resilient, and sometimes utterly indifferent to our curiosity. In these spaces, it is easy to sense that Earth does not exist for us. Every environment we have visited carries evidence of persistence without interference. Rivers carve valleys regardless of the maps we draw. Glaciers advance and retreat with the seasons, and ecosystems continue cycles of growth, predation, and renewal without reference to human schedules. Even in extreme environments where survival is difficult, organisms adapt in ways that demonstrate ingenuity and persistence beyond our imagination. Extremophiles in deep sea vents, microbes in subglacial lakes, and creatures in deserts or high plateaus reveal that life can flourish under constraints that humans cannot endure. In each instance, the planet functions on its own terms, reminding us that our presence is not required for its continuance. Some places remain untouched not by accident. Isolation is not always random. It is often the result of conditions that actively discourage intrusion. Pressure, temperature, chemical composition, darkness, and remoteness create natural boundaries. The deepest trenches, the highest plateaus, and the most remote forests are inaccessible not simply because humans have not tried, but because the environment itself maintains a boundary. In these locations, the planet has established rules for survival that do not include us. Life has found a way within these rules, evolving in isolation and balance, free from interference. Absence, in this sense, becomes a form of protection. Systems maintain stability, populations thrive, and delicate relationships continue uninterrupted. Islands, deep caves, and isolated lakes preserve species and ecosystems precisely because they are beyond reach. The quiet power of isolation allows life to exist as it has for millennia, sustaining processes that are invisible yet essential. Human impact, even in small ways, can disrupt these systems, introducing imbalance where continuity once reigned. In recognizing these boundaries, we are reminded of the responsibility that comes with presence. This reflection also reveals a deeper truth. The value of the planet is not measured by human occupation or utility. The Earth's systems, its diversity, and its persistence possess significance independent of our awareness. Places untouched by humans are not empty or void. They are vibrant, complex, and self-sustaining. Their continued existence depends on the fact that they never required us to intervene, to manage, or to inhabit them. As we pause at the edges of human reach, it becomes possible to appreciate a different kind of presence, one that observes without altering, that marvels without claiming. The planet's boundaries remind us that our knowledge, our curiosity, and even our ingenuity exist within a broader context. Earth continues in its rhythms, cycles, and balances, regardless of human intention. Our place is not at the center of this story. We are observers in a world that thrives through its own systems. In these final reflections, the lesson is quiet and profound. Some spaces remain untouched, not because humans have not tried, but because the planet has no need of us there. Life, in all its forms, endures without our interference. Stability is maintained through absence, persistence is ensured by isolation, and the rhythms of Earth continue in a harmony that is independent of our presence. In recognizing this, we can appreciate the planet as it exists for itself and learn to step softly, with humility and reverence, into the quiet corners it has always reserved.